Hi, welcome to Module 4, the final module of this topic, permutations and combinations. Just some final thoughts. We're going to look at two questions. As you know, when you are facing a question, you need to figure out first whether that question is a permutation or a combination. In the exams, you are not told what kind of questions are this, so you are expected to know. So we're going to look at two samples of questions and try to figure out how we can solve them and how we can look at them. So let's start with the first one. In this question here, it says how many three-letter words can be formed from the letters of word sharing if there are no restrictions. Now, first of all, sharing is a word that has 7 letters. There are no restrictions. So if I have no restrictions, first of all, I need to figure out whether this is a combination or a permutation. Now, when you're working with words, usually it's a permutation because orders do matter. I mean, if you were to write BAD, and then if I were to write DAB, I mean, these are two different words. They're not the same. So in this case, I know that it's a permutation problem. So if I have 7 letters and I want to form 3 words, a word with 3 letters, so there are 7 letters, so there are 7 ways, and then there are 6 ways, and then there's 5 ways because there are no restrictions at all. So this will give me an answer of 210. So that's pretty straightforward. Let's move on to the next question. The 3-letter word will end with the letter H. Now here we have what we have a restriction. So in any situation, we always need to take care of the restrictions first. So again, it's still a 3-letter word. So in this case, the word must end with the letter H, so I put it here, H. Now, I had 7 letters. Now I'm only left with 6 letters. So there are 6 ways to put a letter here, and then there's 5 ways to put a letter here. And there's only one way, a fixed way, which is H. So this will give me an answer of 30. So that's pretty straightforward again. Now let's look at the last part of this question. The 3-letter word will have at least one vowel. Now from this word sharing, we know there are 2 vowels, namely A and I. We do know that there are 7 letters altogether. Now, if you look at this word, at least one vowel, let's figure out what are the possible scenarios. Now, for example, there can be one vowel which meets this condition. There can be at least 2 vowels, but there cannot be any 0 vowels. But if you think about it, these are the 3 possibilities that can happen. Either the 3-letter word has 1 vowel, 2 vowel, or no vowels. Now we are more interested in this, but we also know when there are no restrictions, there are 210 possible words. Now what we can do here is, instead of counting at least 1 vowel, we can actually calculate the very opposite, which is no vowels, which is a lot easier to calculate. So in this case, if I were to calculate that, if I have 7 letters and I remove 2 letters because I won't be using A and I, so there will be 5, and then there will be 4 and 3. This is basically the same as 5 permuting in 3 ways, which will give me this answer. And then what I can do is I can just take this answer here and then take it away from this 210, and I will get the answer that I'm looking for right here, which I leave it up to you to do that. Now let's move on to the next question. Our school chess team has 8 senior members and 6 junior members. A team of 4 members plus a reserve member is to be selected. How many different teams can be selected if A, there is no restrictions? So here we have 8 and then we have another 6 junior members, so that gives us a total of 14. Now here it says in question A, no restrictions. That means out of this 14 people, I just need to choose 5 to be in the team member. Now again, the first question we want to ask ourselves is this a permutation or a combination? Now clearly this is a combination problem because I am not interested in the order. If I were to choose 2 people for the team, let's say person A and person B, it doesn't matter if I choose A first or B first, because it's still the same 2 people in the team, because I'm just interested in a certain type of people. I am not interested in the order that they are chosen. So this is a combination problem. So in this case, if I were to choose 14 people to combine them in 5 different ways, this answer can be found from using the calculator directly, and you will get 2002 ways. So that's the answer to A. Now let's move on to the next part of this question. There must be at least 1 junior in the team. 1 junior in the team. Now let's keep in mind first of all what we calculated in part A, which is 2002, which is 14C5. Now keep in mind this is without restrictions. Now here it says there needs to be at least 1 junior in the team. Now if I were to calculate 1 junior in the team, now then there are many possibilities. I mean, I can have 1 junior, 2 junior, 3 juniors, 4 juniors, all the way up to 5 juniors. That means there's no senior members in the chess team. So in situations like this, it's always easier to calculate the exact opposite, because this is a combination of all types of combinations, and I can just take away combinations that I do not need to get the answer that I want. In this case, what if the whole team simply consists of senior members? That means there's not even a single 1 junior member in that team. So if that's the case, that's easy to find, because then I know that I just need to minus, out of the 8 senior members, I can combine 5 of them. So the team is entirely made of senior members. That means not even 1. The question I'm interested in is at least 1 junior member. So if I were to do this computation here, I will get the answer that I need. In this case, if I were to take 4 combine 5 minus 8 combine 5, that will give me the answer that I need, which is 1946. So keep in mind, sometimes when you are asked certain questions and they are very difficult to find, do the exact opposite. Find the one that is easy and then take away from the total combinations. Okay, so this is something that a technique that we use very often. Not that I cannot calculate that one by one, but it will just be a very long computation. And in mathematics, we are always interested in the lazy way, or the easiest way to get the answer. So let's move on to the next one. C. There must be 2 seniors, 2 juniors, and the reserve member must be a senior. So these are 3 consecutive what we call restrictions. So let's just meet those restrictions. We want a team of 5 people. So in this case, I have 8 seniors. I will combine 2, and then I have 6 juniors, but I only need 2. And then the last part, a little bit tricky, because I need to keep in mind what I have done earlier. Now in this case here, I've already chosen 2 seniors from the initial picking. So I only have 6 of them right now, but I still need to choose one more. So this will be 6C1. Now if I were to tabulate this using my calculator, I will get an answer 2520. Okay, so I hope you understand this. Now let's move on to the last part of the question. There must be more juniors than seniors in the team. Again, this is a very interesting question. Now I need 5 people in this team of chess. So if there were to be more juniors than seniors, let's say these are the juniors and these are the seniors. Since we have 5 people in that team, the only way I can meet this restriction is if I were to have 3 juniors and 2 seniors. The other possibility can be 4 juniors and only 1 senior, or I can have 5 juniors and 0 seniors. Now in some questions you have to initially think of all the possible scenarios before you start tabulating or computing the answer that you need. Now in this case I can tabulate each one of them. In this case this is 6C3 times 6 combined 3, okay, I'm just using the word C, times 8C2, and this will be 6C4 times 8C1, and then the last one will be 6C5 times 8C0. Now these are all the possible scenarios that will meet this restriction, that there will be more juniors than seniors. So each of these answer, once I have tabulated them, I will have to add them because these are the different possible scenarios that can happen. So I will leave this up to you to calculate. If you were to calculate this and add them, you will get the answer of 686. So there you go. We looked at 2 types of question. One was a permutation question, the other one was a combination. I hope by now you have a clear idea how to be to distinguish the different types of questions and also the possible scenarios before you start tabulating. Now questions of permutations and combinations are actually not that very difficult, but before you start any question, please read the question carefully, think through, ask yourself a few questions, and then start doing them. Don't quickly go in and try to answer them without giving it some thought, because sometimes your thinking or your thoughts or how you perceive the question may not be right. That may lead to wrong calculations. It's very important to understand the question first and foremost. So after this, just go ahead and do the final exam. Take your time. You have 50 minutes, but don't take too long, and really think through before you start calculating the questions. And please read the questions very carefully, and if you should have any problems with the final quiz, just send me a tweet or send me a email, and I will look into it as soon as possible. Okay, good luck.